As you can see, watching the electrons, they are going up, they are going down. It is very handy to think of this like gravity. Ground is this low point, and that a high potential energy or voltage would be the positive side of the battery, and then it powers some things using up gravity to go through them, using up gravity to go here. This is 30, and it's a much steeper hill than this one, which is 10, and it's a very small hill. The total resistance in a series circuit is the sum of, this is sigma from the Greek, the resistors. So you add up all the resistors in a series circuit, and that is your total resistance. The current is the same at all points. I, as you recall, is the current in amps. The voltage, right here, you can see 4 volts coming through here. 4 volts minus 4 volts equals 0 volts. The change of voltage equals the change of voltage total equals the sum of the voltage drops. Right here, the voltage drops from 4 to 0. Over here, it's 4, and then it drops 3. Now it's 1. Now it drops 1. Now it's 0. Power is the change in the voltage times the current to figure out the total resistance of this circuit. They're in a series, one after the other, so electrons only have one path to flow through. Now this one is 20 ohms, 25 ohms, 20, 25, 15. The total resistance we find just by adding them, 60 ohms. The total resistance of this one, if R1 is 1 ohm, R2 is 2 ohms, we're going to add them and get 3 ohms. If we find the current, we're using Ohm's law. The change of voltage of the battery is the current coming out of the battery times the resistance of the circuit, in other words, that the battery is pushing it through. So 3 volts is the current coming out of the battery times 3 ohms. If we solve, we see that the current has to be 1 amp. Current is constant in series circuits. So the current coming out of the battery is 1 amp, which is the current at resistor 1 and resistor 2. Voltage equals amperage times resistance. We know we've got 1 times 1 is 1 volt, and 2 times 1 is 2 volts. In this example, we're solving for current. The total change in voltage is 1.5 volts. And to solve for current, divide the voltage by the resistance. 0.025 amps. We know the current is going to be the same at each resistor. So the voltage drop is going to be the current times the resistance. 0.25 amps times 20, 0.25 amps times 25, 0.25 amps times 15. The voltage drop times the current is going to give you the power.